Hello, Maha and Fuad. This is a quick video just explaining the files that I'm sending you guys. So I have a 01 final model development batch script that only creates the final and the best model. It's very focused with only the variables within the best model and the best method and so far. Final model apply in IPython notebook, and the 03 final model apply batch script that is a .python. I'm gonna run the third first. So to run the third, I basically need to go to CMD and enter in this directory where I can see that the files are here. And once we have it, it's going to tell you that it's importing the data. It's gonna take a while, so I'm gonna pause the video and I'm gonna open Spider just in order to show the code that is actually running. You don't need Spider to actually just see the code, but the code is in here. So I'm telling you that to actually run the code, you need to have scikit-learn version 0.21.3 and joblib 13.2. And that's because I'm loading both the model and one transformation here that requires those versions because I trained the model. You can, if you have different version, you can either force the reinstall to my version, or you can retrain the model that is running the 01 file that is in here, final model development batch. So you can retrain the model, and then you're gonna have these two objects in here, those two that I'm importing, created in your own version. This only runs on Windows machine and only runs with this version of scikit-learn. If you have different version, you can either reinstall it or rerun the 01 that will create the objects, the joblib objects for your Python version. And if you own Linux, that's a mandatory to create the version, to create the objects again. So let's come back to here and see what's going on. So yeah, it has imported the data, loaded the model, and imported the variable transformation. It calculated the months and book, applied. It's applying the model right now. It's going to take a while. So let's see. And it's going to say that it's going to be exported. So I can just explain what the code is doing. The applying one is exporting from an Excel. We can change it to different formats when they come with the final requirements for the actual run, and it's importing, loading the RBA, know your customer joblib, that's the model, then the transformation in here, applying the transformation to the new variable, then calculating the months on book, that is a variable that I received the date of assessment, but I calculate how many months the customer has on book based on that. And then I get the final variable. So you have 1, 2, 3, 4, 5, 6, 7, 8 variables in the final model. So I actually reduced a couple more variables because it wasn't improving anything else. So, and then I get the RBA value here. I don't use this RBA value anyway, so I can get rid of this. And because I'm creating the predicted one right here, and then I apply the predicted one back to the data frame and export it to the scored Excel again. So I'm gonna have a RBA score.xls that is gonna have a new column with my prediction that I'm gonna show right now. Now we can see that the 050 exporting score data. So in a while we're gonna see the data exported. So yeah, we finally have it. So if I say dir here, I have a new file called RBA know your customer accounts all IDs scored that I can come in here. So the new file has appeared. I can then open it. and you will see that at the last column is my RBA predicted. So this is 13.19, this is the original 13.2, this is 1691, this is 1693. Sometimes, yes, I get it wrong, like in those cases, as you can see, 13 and 21. Then this is 15 and very close, 14, 14, 16, 16.4. So this is without actually knowing this. I just got the object. I didn't even look to this, only with 8 columns and all the data, I was able to predict this value. Sometimes I got it completely correct. Sometimes I got it close, like this one. Well, it's not that close, but anyways, it's good enough for 8 variables. And so that's the prediction of our final model. So I guess this is what you guys have to show the client. In any case, I'm gonna open the notebook and gonna show, well, this 02 final model apply batch script is the same as the Python script, but in a notebook format. You don't need to worry about this one, okay? And this one is the final model development. It doesn't have all the, the playing around that I do for developing for choosing the best parameters, the best model, the best variables, transforming. I've tried many different things, but in any case, it just do all the necessary, like dropping the variables, doing a Python vectorize here to create a month-sum book, apply the transformation only for the variable that we're gonna use in the end, and then getting the X and Y here, doing the train and test split. Then finally, we've chose a random forest regressor with those parameters were the best ones that I've came across. So this is the one to fit the model. So then I do my assessment here, just to see that I've get correct on the 94% of the cases with the correlation, Spearman correlation. And finally, I dump the model and I dump the transformation. Those are the 2 files I need to have for later to actually apply the model. Coming back to the directory, you can see that the RBA Know Your Customer model has 2 gigabytes, so like 3 gigabytes, and run nationality original label encoder, or 2 kbytes. So 2 kbytes. So, well, basically those files, you do need them in order to apply. And why is this so big? It's because the actual trees that are inside are massive in size, and they are as well many trees. So the model is a very complex one, but it applies very, very fast. And I think we got it correct. Was the best I could do. I think it's enough for this time. And then I still have to, but in the future, when you come back to me, I'll prepare the list of variables and we fix the code to whatever option you guys tell me, if you're gonna go for a batch process, and if they're gonna change the type of the files, not being Excel, being a flat file, whatever they tell us, we can do it, okay? But I think this is enough for demonstration. So thank you very much. Hope you liked the final result.